Hey guys, so this is a video explanation for the homework that I sent yesterday. I think it was pages 99 to 101. So it's telling you a smooth incline, so no friction, an angle theta. It's important that you read these things through to get all of the details that they want you to include. But it's also important that first you look at the prompt, because this is the prompt. This image is the prompt, right? What I see here before I read through this is that I have a force that's acting horizontally, that's acting parallel to the plane, and another force that's acting in the horizontal plane, so not parallel to the plane, right? So just by looking, I expect this force to have two components, one along the plane, right, and one perpendicular to the plane. So in case they talk about normal force, then I know normal force will be influenced by that perpendicular component. In case they talk about motion, I know it will be influenced by that horizontal component. So let's see what the question is asking. In the two cases, the cart is pushed up the incline by a force F whose magnitude is greater than the weight of the cart. Good. This is going to be important, and I'm going to show you at what point it becomes important. In case A, the force is applied parallel to the incline, just as you see, and in case B, the force is applied horizontally, so there's components. In both cases, the cart is pushed up a length L, so the same length is traveled using the same, the force in different ways is the same length. So that tells me kinematics might be involved. And attains a final speed VA in case A and VB in case B. That confirms that kinematics is going to be involved for sure. So part 1, explain why, the two speeds are related by this equation. Explain why this is the case by discussing specific forces and force components. Now when you look at this diagram here, the entire force is used to push parallel to the plane, right? But when you look at this force here, only a component of this force will be responsible for horizontal movement of the block of the cart along the plane. Only the horizontal component will be responsible for that. And since I know that this horizontal component will be F cosine theta, there is no way that component is bigger than F, right? So for sure this F will be bigger than F cosine theta, because cosine of theta is for sure less than 1, right? Cosine of theta is going to be less than 1. So, and this is a mathematical idea that the cosine of theta is less than 1, so therefore F cosine theta will be less than the full F. So first of all, I have used the force components of the force itself and the specific force to discuss that idea. The other thing that I know is that this cart has a component of the weight, right? It has a component of the weight, because remember the weight is acting downwards. It has a component of the weight called mg sine theta that's acting down along the plane. But since it's the same cart, then that's the same component, mg sine theta and mg sine theta. So since it's the same component, the equation of motion for this cart up the plane is going to be, in case A, it will just be F, right, minus mg sine theta, since I don't have friction, and this is going to be your net force, because net force is equal to mass times acceleration. That is in case A. In case B, still I'm using net force equals ma. The net force, looking at the forces acting up the plane, I have F cosine theta, and down the plane or down the incline, I have mg sine theta is equal to ma. Now this acceleration, this is a2, this is a1. The acceleration is related to the speed, and since acceleration is related to the speed, and obviously the acceleration in A is going to be bigger than the acceleration in B, because this term is the same as this term, so the only thing, the mass is the same, right? The only thing that's mattering, that's causing a difference, is the F, and since F is bigger than F cos theta, this V is definitely going to be bigger than this V, right? So try to put that in words using equations or etc, but you're explaining, so that means you're using your words, and then you can use equations where necessary. So I can check your work to see that. Part B tells us to explain why this is the case by discussing specific energy transformations. Now, this guy, in each of them, work is being done by this force, right? This force is doing work, this force is doing work. So in case A, the work done is equal to that force times the distance L. And in case B, the work done is equal to the work done along the plane. And I know you might be thinking, but isn't some work done by gravity? I'm just considering the system along the plane. So good question there, Georgie. I'm considering along the plane, up along the plane, right? That's what I'm considering. The work done to move it up along the plane is simply due to this force F, right? Or even if it's the net force, okay, let me use the net force. If I still use the net force, it's going to be F minus mg sine theta, which I'm supposed to be using net force. Thanks, Shuad. So net force, and again net force times distance times, which is the L, the length that it covers up the plane. The net force in this case is F cosine theta minus mg sine theta. Still, I can see that the net force in case A, this net force is going to be bigger than F net in case A is bigger than F net. This net force, like this whole bracket, is going to be smaller. This is F net in case B. This is going to be smaller than F net in case A. Since the F net is bigger, that means the change in kinetic energy in this case is bigger than the change in kinetic energy in this case, right? In B, the change in kinetic energy is smaller than the change in kinetic energy in A, because work done needs a change in kinetic energy, and therefore the final velocity in A is going to be greater than the final velocity in B. So please, because if you write these things just the way I've written them here, and someone looks at them, I don't think they can clearly reproduce your thinking process. So it helps if you use words, right, to accompany these explanations or these equations if you decide to use them. Using either Newton's second law and a kinematics equation, or using principles of work and energy, write the equations for the following in terms of mg, L, theta, and F. The speed VA. Now, taking you back here, this was my equation of motion for object A, and I'm just going to use this equation of motion to figure out what the acceleration is, and this equation of motion for B to figure out what the acceleration is, because this is asking me for speed VA and speed VB. So for A, I remember that F minus mg sine theta is equal to ma. If I make A the subject, computer charging, if I make A the subject, I have A acceleration in system A, acceleration in A is equal to F minus mg sine theta divided by m, right? And I hope I'm just going to do B just over here. In B, my equation was F cosine theta minus mg sine theta is equal to ma in system B, and A in case B, or system B, is equal to F cosine theta minus mg sine theta divided by m. That's the acceleration. Now I know this kinematics equation, v1 squared is equal to v0 squared plus 2 acceleration delta x. The delta x in both of these cases is L. So I'm looking for v1. I know it started at rest, so this is 0 in both cases. So my v1 squared A, right, is going to be on, or I can just call it VA squared, is going to be 2 times the acceleration of A, which is this whole bracket, F minus mg sine theta divided by m, right? That's my VA, and times displacement, which is L, and my VB, so V1 in B squared, is equal to 2 times acceleration of B, F cosine theta minus mg sine theta divided by m, still times L. So I've got the V of A and I've got the V of B in terms of what they want. I just need to take square root so that it's clearly what they want. So this is 2f minus mg sine theta divided by m square root, and this is VB is equal to 2 times f cosine theta minus mg sine theta divided by m, this is a bracket, times L and the square root. So those are the velocities in terms of the quantities that they want. And finally, explain how your two equations from part B support the idea that VA is greater than VB. Also explain how your two equations support your answer to either part A Roman 1 or part A Roman 2, depending on whether you use forces or energy in part B. So here I can see that everything else about these velocity equations is the same. Let me use green to show you. I have divide by mass, I have divide by mass. I have a square root, I have a square root. I have a 2 and a 2. I forgot an L here. I also have an L here. So the only thing that's different, because I still am subtracting mg sine theta and still I'm subtracting mg sine theta, so the only thing that's different that's affecting the speed is this component f cos theta and f, and that supports all of my arguments, because according to that my VA will be greater than VB, which supports my argument in this part 2, which supports my argument in this part 1. So yeah, you can put that in normal words and explain it that way. Hope that helps.